sols, and over on the other side are oxasols, another group called the mollisols, which we described earlier, and iridosols. What are they? So an entisol is just a soil that's being developed basically right now. This is a recent soil. And basically you take this entisol and you begin to exact chemical weathering processes on it. Now, depending on the climate, you're going to get different kinds of processes occurring. For example, in a permafrost environment, you're going to get something very different than what you're going to get in a rainforest. So here we have an entisol. It's recent, and if we put it, for example, into that permafrost, it follows this track right here, it'll form a soil called a gelisol. All right. This is very cold. And how much weathering and soil development occurs? Well, it's just slight, it turns out, right? Because if you can recall from our discussion on weathering patterns, you need to have a lot of high temperatures. You actually have to have higher temperatures to get good chemical weathering. Otherwise, you only get slight chemical weathering and mostly physical weathering. So it turns out permafrost tends to generate gelisols. Well, what if we get strong weathering, like what we see over here? Well, that would be the oxasols. And we find that occurring, of course, in wet tropical rainforests. We get extreme weathering. Don't worry about the clays and iron oxide stuff. But you'll see that oxasols tend to form here. And this is a very, very stripped out. It's well developed, but all the nutrients are stripped out. And this is what we find in tropical rainforests. We'll come back to why this is important for ecological purposes later on. Mollisols, this is kind of in the intermediate. These are usually in grasslands, semi-arid to moist. So it's right in the middle here. Alpha sols, of course, the same thing. On the other side here, where it's mostly mildly acidic clay accumulation, right here. Okay, so you kind of get the idea how these kind of arise from the development of diagenesis and the breakdown of igneous rocks and even metamorphic and sedimentary rocks to form soils. So here we see these global regions where all these 12 soils exist, right? Here are the alpha sols. They come up a certain color, and andisols. Let's go to the ones I brought up, right? The gelisols, I just said these tend to form in cold environments. Well, it turns out here are the gelisols up here at the northern part of Alaska, into the Klondike region of northern Canada, all the way up into the areas just to the west of Greenland. And then back over here, this is Siberia, into northern Russia, the Kola Peninsula, and even down into the Moscow area. Very cold area. Very, very, very cold area. And you get really nice gelisol development in these areas. And so the types of plants that grow on gelisols tend to grow in these areas. Okay, alternatively, remember we're talking about oxasols. Oxasols are these areas of extremely high chemical weathering. Remember this right here, way over here. We come back to our map and look, we see oxasols was pink. Here's that pink color right through here. This is the Amazon rainforest. Here we actually find the same kind of forest environment here. We'll find little patches of pink in here, but you'll notice it's all kind of at the same latitude moving through here. It's the tropics. All right, we get oxasols. What about some of the best places for pasture land, the best grass? Well, those would form on mollisols, right, the grassland. And sure enough, we've got mollisols that form over here in eastern Argentina, southwestern Brazil. But most famously, notice the grasslands here in the United States, all the way up into southern Canada. This is the famous food growing areas, Iowa and Kansas. And then, of course, over here would be northern China and southern Mongolia. We have beautiful grasslands that extend literally all the way to eastern Europe. These grasslands here were conquered by Genghis Khan, and we see a very strong influence of Asian culture that came in along these grasslands because of the ability of these people to transport goods and services and to cultivate them very easily. All right, so this is fantastic. This is basically the bread belt of Russia, and here's the bread belt of the United States, and of course of South America. you can see pretty rapidly why understanding soils is so important to your understanding how your economy actually works. Right? You would want to know something about how an ultrasol works if you're living in the southeast. If you're in an aridisol, this is a desert climate, a desert soil. Well, that's over here on the other side. So, anyways, you kind of get the idea. All right, so beyond that, we can actually start to differentiate more than just an ultrasol or an aridisol or an oxisol or a paleosol. Turns out that the soil taxonomy then breaks down to, okay, you have an oxisol. What kind of oxisol? And so there's suborders, bunches and bunches of them based upon moisture regime and mineralogy. Then that can get subdivided again to diagnostic horizons, whether they exist or don't, subgroups beyond that, and you get the idea. And so ultimately you can get to a series, and that means you have about 13,000 different soils that have been categorized just so far. And probably by the time the human species is done categorizing soils, we'll probably find 5-6 times that. Who knows? It depends on how much we want to split that argument up. So it turns out that you can do serious damage to your soils. Your soils are a resource. They are relatively finite. The Earth is constantly remaking them. But in some areas for example, in Hawaii, you're able to generate new soils within about 80 to 100 years. That's still about a human lifetime. But if you're in an arid area, such as in Sudan, soil development could take centuries. It could actually take more than centuries. It could take millennia. All right. So in this case, this is actually a picture of Sudan. Let's go ahead and read through here. The agricultural productivity of soils can be improved through fertilization and irrigation. That's what these guys are trying to do. So here we have a field. This is a degraded soil, and they're basically trying to treat it. They're trying to save this field. And the soils can be damaged or destroyed by careless activities. The problem with damaging your soils is that this is crucial for providing food, fiber, and other basic materials. Fiber being things for paper, and of course, it is one of the most abused resources. We take it for granted all the time that it's there. Here in Sudan, this is actually an old plantation, and the plantation, of course, doesn't look like a plantation anymore. At one time, the soil was much higher. You can see this kind of puffed up area, or this area that looks like it's pushed up. It's not actually pushed up, it's that everything else is washed away, and this has been left high. This is the old E horizon. The A horizon here has been completely stripped off. And so what they're trying to do is they're actually trying to use tractors and whatever to try to rip up the B horizon and to try to force it to be productive. You can tell they're not terribly successful in doing this at this time. All right, so clearing the rainforest, it turns out, has an amazingly bad effect for rainforests, I should say. So let's look at this human activity. First off, we see that this bulldozer is clearing it out. The soil is this orange color. It's not black. It doesn't have a whole lot of organic material. And the reason why is, and we've talked about this, the reason why I picked this as an example, is because we are dealing here with wet tropical forests. These are oxisols. So in other words, there's a lot of iron and aluminum oxides in the soil. The soil does not have a lot of organic material. It's very strongly developed, but not a whole lot of organic material. It turns out that rainforests sustain themselves by recycling that O horizon very efficiently. So let's come back to this. So here we could see, here's the O horizon, which of course is the forest, and right below it, we're basically straight into the oxisol. There's almost no nutrients here. The rainforest is recycling carbon like crazy right here. And when you strip this thing out, you're actually removing the O horizon. What can grow here after that? Nothing. And an observation of areas where they've tried to rehabilitate these rainforests show that they don't actually rehabilitate the rainforest itself. It turns into a grassland, and in some cases it actually turns into a desert. So this is really a bad way to kind of clear land. A lot of these rainforests have been in existence since 100 million years, especially in the Brazilian, the Amazon rainforest. Okay. So that's in fact what this says. Soils in tropical forests are poor in nutrients and unsuitable for agriculture. You cannot grow things here. This is really a bad way to try. You cannot grow corn on this. Most of the nutrients in tropical rainforests are found in the trees. And so sometimes they burn the trees and then try to force the ashes into the soil. That's not really a very good way of doing it either. And of course, clearing soil or clearing the tropical rainforest also promotes soil erosion. So it just makes the whole thing, it's a bad situation all around. It's really not the way to go. All right, so here we actually see a field. There's a couple of people here, or there's a person standing here and a person standing here. And between them, you can see this field is being deeply eroded. This is recent erosion. The reason why we know it's recent erosion is because if it was ancient erosion, we'd have deep gullies here. This has just occurred recently. So this is where a farmer has come through and cleared his field. Unfortunately, by doing so, he's removed, and I'm assuming it's a him, removed basically what erosion control existed naturally, which was probably some native plants that were there at the time. By removing that and putting his own agricultural product, whatever this may be, grass or alfalfa or whatever it is, it wasn't able to stop the rain, and the rain was able to start washing it away. So here it ripped it up, and here it's deposited it down here. Not necessarily a good situation. I've actually heard farmers refer to this kind of erosion as cancer of the land. It's a real bad phenomenon, especially if it happens over long periods of time. So erosion rates are dependent on climate, slope, and type of vegetation. Human activities such as deforestation and farming practices can enhance soil erosion. That's what's being demonstrated right here. All right, so let's talk about some of the byproducts of the weathering and the formation of soils. So weathering creates deposits by concentrating metals into economically valuable concentrations. This is called secondary enrichment. Remember those oxasols. I like oxasols because it's probably the easiest one to conceptualize. Remember that nice red color that soil was? That soil was turning red because everything was being leached out of it, but iron and aluminum oxides were being retained and even in some cases concentrated. And so you get a mineral or a rock called bauxite. It's actually a mineral. And it's the principal ore of aluminum. It's aluminum oxide. And is found in rainy tropical climates from chemical weathering and the removal of undesirable elements by leaching, right? So this is right out of what you would consider the E-horizon. And this is where we get our aluminum from to make all of our aluminum products. There are other sources of aluminum as well. Bauxite is the most economical way to do it. Okay, so it turns out that not only are you producing bauxite, but soils actually produce some other really cool byproducts and ore deposits that are really useful to us. For example, copper and silver are frequently deposited in this way, not always perfectly into the soils, but as a byproduct of the weathering and formation of soils. So, these typically occurs in deposits containing pyrite, where you get the copper and the silver. They tend to go hand in hand. But here we see, this is copper carbonate right here. This is two different minerals. This is azurite. This is copper carbonate. And this is copper carbonate. Notice that copper, when it's combined with a carbon, or with carbonate actually, forms these beautiful blue colors. And so this is a product of weathering, and this is copper ore. This is where we get most of our copper wiring from, is from minerals that look like this. Pretty interesting stuff. Malachite and azurite, under a microscope, it's a really beautiful mineral to look at. All right, so I hope you enjoyed this little lecture. I know that we kind of went through it pretty quick. Soils, like I said, there's a whole science to it. I mean, you can go through an entire class on each one of those orders that we were talking about, an oxasol, an alphasol, and you name it. And we just kind of breeze through it. But if you have an interest in this, usually most colleges and universities offer soil science courses right there on campus, where they deal with, for the entire semester-long subject of soils and their formation. So anyways, just thought I would throw that out there. Anyways, if you have any questions or there's something that you need cleared up that you didn't understand from this lecture, feel free to send me an email or meet me on the discussion boards. Until next time, have a good one.